I thank you all for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of July 2024. The question is from the section Analysis and it is related to the concepts of limit superior and limit inferior of a bounded real sequence. This question is from the part to B, which is a multiple choice question, and it carries 3 marks. The question ID is 704024. Right. The given question is, let n greater than or equal to 1 be a bounded sequence in R. It is a real sequence and it is a bounded sequence. Which of the following is false? We have to find out the false statement. We are given 4 options. Option 1, if limit inferior an and is equal to limit superior an, they are equal. If they are equal, then the sequence an is convergent. Option 2, if infimum of the set consisting of n greater than or equal to 1 is equal to limit superior of an, then the sequence an is convergent. Option 3, if supremum of the set n greater than or equal to 1 is equal to limit inferior of an, then the sequence an is a constant sequence. Option 4, if supremum of the set consisting of n greater than or equal to 1 is equal to infimum of n greater than or equal to 1, supremum is equal to infimum, then the sequence an is constant. Let's now discuss the solution of the problem in detail. We are given a sequence n is equal to 1 to infinity is a bounded sequence in R. It is a bounded real sequence. Right. Let's call upon the option 1. If limit inferior an is equal to limit superior an, then an is convergent. Then an is convergent. The bracket an is missing here, n is convergent. Let's now recall a result. We call it result 1. A real sequence n greater than or equal to 1 is convergent if and only if limit inferior an is equal to limit superior an is equal to limit of an. Limit n tends to infinity of an. So this is the result what we have. Now limit inferior of an is equal to limit superior an implies n greater than or equal to 1 is convergent by the above result. Right. So therefore the option 1 is true. Let's move to the next slide for the next option. Right, we call on option 2. If infimum of an n greater than or equal to 1 is equal to limit superior of an, then the sequence AN is convergent. Right. So given infimum of the set AN, n greater than or equal to 1 is equal to limit superior of AN. Now, we have already seen the result 1. We recall result 2. For any bounded real sequence AN, n greater than or equal to 1, infimum of AN, n greater than or equal to 1 is less than or equal to limit inferior of AN, is less than or equal to limit supremum of AN, is less than or equal to supremum of AN, n greater than or equal to 1. This is the result what we have. Right. Now, by result 2, we have infimum of AN, n greater than or equal to 1, is less than or equal to limit inferior of AN, is less than or equal to limit superior of AN, is less than or equal to supremum of AN, n greater than or equal to 1. The above result we have quoted. But now we take infimum of AN, n greater than or equal to 1, is equal to limit supremum of AN. This is what we have. It is given to us. Now substitute here infimum of AN, n greater than or equal to 1. In this place we write limit supremum, limit superior AN. So in this place we write limit superior AN less than or equal to limit inferior of AN is less than or equal to limit supremum of AN. So in the place of infimum of AN, we have written limit superior of AN. Now this much is sufficient for us. Now the limit inferior of AN is squeezed between limit superior of AN and limit superior of AN by the squeeze theorem, that is the sandwich theorem. Limit inferior of AN is equal to limit superior of AN. And if it is so, by result 1, the given sequence is convergent. Thus, option 2 is true. Agreed. We go to the next option. Option 4 we have considered here. If supremum of AN, n greater than or equal to 1 is equal to infimum of AN, n greater than or equal to 1, then AN is constant. Okay. Now, given supremum is equal to infimum, by result 2, we have infimum is less than or equal to limit inferior, is less than or equal to limit superior, is less than or equal to supremum. And supremum is equal to infimum. So now in the place of infimum, supremum is equal to infimum we are given. Then inferior infimum of AN is less than or equal to limit inferior, is less than or equal to limit superior, is equal to, in the place of supremum we have written it is equal to infimum of A. So again use the sandwich theorem. We get infimum of AN is equal to limit inferior of AN is equal to limit superior of AN, you will get from this. But we have infimum of AN is equal to supremum. So we get, in the place of supremum, we get supremum again. We write supremum. So the infimum is equal to limit inferior is equal to limit superior is equal to supremum, for which of a bounded sequence all these four are equal. This implies the sequence AN, n is equal to 1, n greater than or equal to 1 is a constant sequence. For constant sequence only, all these are All these exist and they are equal. Therefore, the sequence a and n greater than equal to 1 is a constant sequence. Thus, our option 4 is true. Right. We are left with the third option. Option 3. If supremum of an is equal to limit inferior of an, then the sequence an is constant. Is it so? Not necessarily. Not necessarily. For this, we consider the sequence n greater than or equal to 1, where an is equal to 1. When n is 1, an is equal to 1 minus 1 by 2 to the power of n minus 1. When n belongs to n minus the singleton 1. So that means n is equal to 2, 3, 4, so on and so forth. So the sequence is 1, 1 minus 1 by 2, 1 minus 1 by 2 square, 1 minus 1 by 2 cube, so on and so forth. And it is a bounded sequence. Bounded above by 1, bounded below by 0. Right. Clearly, it is a bounded sequence. And the supremum of an is 1. Yes, supremum of an is 1. Note that limit n tends to infinity of an is limit n tends to infinity of 1 minus 1 by 2 to the power of n minus 1. That is 1. Because limit n tends to infinity of 1 by 2 to the power of n minus 1 is 0. Thus, note that limit n tends to infinity of an is 1. That means this sequence is convergent. When it is convergent, limit inferior is equal to limit superior is equal to limit of the sequence, that is equal to 1. Agreed. So, for this sequence an, we have supremum is 1. The infimum, limit inferior is also 1. Supremum is 1 and the limit inferior is also 1. But this is not a constant sequence. But an is not a constant sequence. Therefore, this is not necessarily true. Therefore, option 3 is not true. So, summarizing all the options, the answer to this question is option 3. Why? Because we have to identify that option which is not true, which is false. The false option is option 3. The remaining option 1, 2 and 4 were true. Thus, the answer to this question is option 3. That is the detailed discussion of the solution of the given problem from the analysis, which is related to the concepts of limit superior and limit inferior of bounded sequences. It is definitely an interesting question. It's not that easy. It is little difficult. I am sure that you have understood the solution of this problem. I thank you all for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.